Well, today is Thursday, April 16th, 2015. My name is Mark Caruso. We're in Tampa, Florida at the MUSC International Conference, and we're going to be interviewing Joseph Sistino today. Welcome, Joe.
Thank you. I'm glad to be here.
I have to tell you that the names of individuals to be interviewed was submitted by the MUSC Executive Board, and I refused to get involved in the choosing process. So I think it's important for you to know, as well as the other interviewees, that your peers have selected you to be interviewed.
Thank you.
The purpose, I think, is to not only just capture the footage today, but at some point we may take some excerpts from the pioneer interviews and put them on the website. It's my hope, too, that we'll do a transcript, and of course we'll let you and all the other interviewees have a chance to see what the edited final version looks like. So without further ado, I'd like to ask you, what were the circumstances that led you to get into perfusion? What was your background before you got into perfusion?
Well, when I found out about perfusion, it was actually when I was in high school. I was in AP biology class, and I wrote a paper on open heart surgery. It was 1970, May 1970. I actually still have a copy of that paper at my house. And I was going to show it yesterday at the award ceremony, but and there's a whole section in the middle on cardiopulmonary bypass. One thing it does say in there is that the surgeon stops the heart, and that was just at the beginning of cardioplegia, so I don't know how accurate that was, but I knew there was this thing called the heart-lung machine, and it was used for heart surgery, and it also said in that paper that there were a lot of cardiac conditions that were not correctable by heart surgery. So that was before no-OAT operations, single ventricles, and everything. And so I remember one time when I was first started working, hearing about a patient with a single ventricle, and they said that nothing could be done for that patient. So, but that's what I knew in the back of my mind that there was such a thing as a heart-lung machine. And when I went to college, I got involved in the ambulance corps at our university. I started an ambulance service on campus. And I was very active with that in the first 2 years. And then I got into this cardiorespiratory program at the State University of Stony Brook. About 4 years ago, I got a call from the State University of Stony Brook saying that ambulance corps has 2 buildings now and has a budget of $500,000 a year. And so it's still in existence. I had no idea. And there's 150 people that are part of that department now.
Wonderful.
So I was the first president of that. So I started that in school, and then I heard about this cardiorespiratory program, so I went into that program. And that program was a combination of respiratory therapy, cardiopulmonary technology, and perfusion. So we did rotations in all 3. So that's how I learned about perfusion through that program. And then after I graduated, there was a job available in respiratory therapy, so I did that for about 6 months until a job became available in perfusion. And I started at Long Island Jewish Hospital in perfusion with Richard Chan.
Okay, I'm going to ask you to stop the tape.
Sure.
There's a thread right here, Joe, and I'm sure the camera's... I'm going to stick it back in your pocket.
Okay,
there, we got it. So you did your we're back on tape. You did your undergraduate work at Stony Brook.
State University of Stony Brook, and it was mostly cardiorespiratory physiology with a small perfusion component to it.
Really?
Yeah.
And you mentioned Richard Chan. When did you first come in contact with Richard? He
was a clinical instructor. He actually came out to Stony Brook, gave some lectures. Him and Richard Narvez he was the chief. Rick Narvez was the chief, and Richard Chan worked with him. They came out, did lectures, I believe we did an animal lab too out of Stony Brook, and then I did a clinical rotation at Long Island Jewish Hospital.
So they both were at Long Island Jewish and would go out to Stony Brook to lecture.
Right.
Okay. Well, you had a job as a respiratory therapist, is that right?
Yeah,
and how did you transition over to perfusion?
So the job in respiratory therapy was at St. Francis Hospital, which is a nearby hospital, which used to be a place where people went with heart surgery to basically die. There was no treatment for heart surgery before the 1950s. So like a sanatorium, maybe? I'm not sure if you'd call it that, but it's a place where people with congenital heart disease to go and die, and then they eventually created a cardiac program there. But when I was working there in respiratory therapy, all the patients were dying. The whole ICU was filled with patients on ventilators, and they were all dying after heart surgery. And I would see patients before surgery, and half of them never would come out after the surgery. So after a couple of months of that, when I got the job offered the job at Long Island Jewish, I went back to Long Island Jewish. Now, at that time, Long Island Jewish published a paper. They did 300 cases in a row without a mortality, mostly cabbages, and they were very good at that. There was no ICU. The patient went right into the recovery room and was extubated right after surgery. Very fast pump runs, and the patients did great. But then when I went to this other hospital, I worked in respiratory. The results were very poor. Eventually, they published mortality rates for that hospital. They were 10% in the newspaper, 10% mortality at that time. So anyway, I learned a lot of good techniques at Long Island Jewish. And then in the interim, I went to work at another hospital called Nassau Hospital, where I was the only perfusionist for about a year. And at that hospital, they were using a Cleveland Clinic technique of bypass. They had two venous lines, 2 3/8 venous lines that came all the way back to the venous reservoir. And I basically took their circuit and made 2 perfusion circuits out of 1 tubing pack. There was so much tubing. And I worked there for a little while, and then I was asked to go back to Long Island Jewish as the assistant director. I was pretty young to be in any kind of management role, but it was a good experience for me.
Sure. So the courses that you got at Stony Brook were really sort of introductory courses. Your perfusion training didn't start in earnest till you went to Long Island.
Right. When I went to Long Island Jewish, I read every perfusion book I could get my hand on the time I was there. And I remember I did a case report. I had to do a case report at the end of the rotation with the surgeons and the perfusion staff. And my patient was a bus driver, New York City bus driver. And I found a paper comparing bus drivers to train conductors and the incidence of coronary disease. Now, I don't know how I found it because there was no internet search at that time. But I found it, and it showed there was a much higher incidence of coronary disease in bus drivers.
No kidding.
Sedentary and the stress of driving in a crowded city. So I think when I did that presentation, they were pretty impressed that I found that paper, you know. And so it was a really good experience for me to be at Long Island Jewish.
Well, you referred to some books that you could put your hands on. What books stand out during your training?
Galletti, I read that from cover to cover numerous times. John Norman's book on cardiac surgery. And that had a portion of a chapter written by Jim Deering. And he talked about perfusion as a profession. He talked about the need for university-based perfusion. And at that time, there was controversy with other perfusionists whether it should be university-based or post-college certificate program. And so Jim Deering, in that article, talked a lot about the university program that he established at Ohio State. So that's when I first realized it was a real profession.
Sure.
Yeah.
And where did you present the case report? Was that locally?
Yeah, that was just at the surgeons at the end of my clinical rotation.
At Long Island?
Yeah, at Long Island.
Okay.
Jewish, yeah.
Well, can you, now that we're on that track, can you remember your first national presentation?
Oh, yeah. Well, I sort of got encouraged by Jeff Riley to get involved in presenting. I presented at a local meeting on a patient that needed a liver resection. It was a child, and we used bypass as a rapid transfusion system. So I presented that at a meeting in New York, and Jeff Riley was there, and he was the editor of the journal at the time. He came up to me and he said, you should really write that up. So I wrote that up, and then the first time I actually presented was at an AMSEC meeting in California, in Anaheim. And at that time, we didn't have PowerPoint, so we had to use slides. And I got these special blue slides so that the writing was the typewriter was in white with blue background.
Blue diazos.
Yeah, we spent a lot of money getting those slides. And that was the highest technology at that time. So it was a national meeting. So I went out into this auditorium, and it was a beautiful, almost like a theater, wraparound theater, and everybody was in the audience, and it was packed. The room was packed. And I could not really see anybody in the audience when I got up to speak. But the room was full because the speaker before me was from Johns Hopkins, and they were talking about separation of conjoined twins on bypass.
Oh, my goodness.
So that was just an amazing presentation. I had to get up after that. And I did a survey of blood conservation techniques after bypass, how people were, whether they were cell-saving the blood, or whether they were hemoconcentrating, and it allowed me to read a lot of papers about blood conservation. I was very interested in blood conservation during that time.
Sure.
And that's an interesting story, how I got interested in blood conservation. So,
well,
okay.
I'd like you to tell me about that in just a moment, but I'd like to know how long your formal training was when you were trained by Richard and others there at Long Island.
It wasn't that long. It wasn't really that long.
I mean,
once I started the job, that's when it really got, that's where my training really occurred. The school part was not that long.
Okay.
Very short, because we were trying to do respiratory therapy, cardiopulmonary technology, and perfusion. So we had rotations in all those areas. So.
Okay.
But they weren't that long, the rotations.
Well, I preempted you. You were going to talk about blood conservation and your early interest.
I got really interested in blood conservation around 1980. I had a case at a hospital, and at the end of the case, the patient was bleeding. So the surgeon said, give the protamine, and then just turn the pump off when the pump clots. And so we went through those steps, and the pump clotted, and then the surgeon turned around and said, set up another pump. So that happened twice. One I remember was a mitral valve where it was a Bjork-Shiley valve that tore through the back of the left atrium and was not repairable. And but anyway, I went to the other surgeon who was chief, and he says, you have to start using these cell saver devices. They just came out, cell savers. So I went to a meeting in Boston at Hemonetics, and I learned all about cell savers, and I became very interested in blood conservation. I mean, and at that time was the beginning of the AIDS crisis, 1981, 82. It was just, blood conservation was just really important. So I got interested just in time for that. So that's how I ended up doing the survey, like a couple of years later.
How long did you stay at Long Island
I was there for
Jewish?
5 years. And
5 years.
Yeah, and then there was a job opening at Montefiore Hospital in the Bronx, and a chief position. And I was 26 years old, and I applied for that job, and I didn't really think I was going to get the job. But I think I got the job because I was almost done with a master's in hospital administration. So I started that a year after I finished at Stony Brook. I started going at night and on weekends and get my master's in hospital administration. And so, they did grill me on physiology and cardiac and pulmonary physiology as part of I had a cardiologist and a surgeon both grilled me on physiology. And then I think the fact that I was going for a degree, I think it really helped a lot.
Sure.
There were a lot of other people that applied for that job, I know for sure. And I was definitely the youngest one, but I got that job.
And how big a team was there at Montefiore when you started, Joe?
There were 9 perfusionists there, and none of them had been trained formally in perfusion. They were all on the job trained, and a lot of them were transferred from other departments in the hospital. One worked in the warehouse and in shipping. Another person worked as a pharmacy tech. A couple of people, I don't even know where they started. They had no formal education, medical education at all. They used 3 perfusionists to do perfusion, 1 to watch the level, 1 to scrub in and hand off the lines, and the other person to run the pump. It's 3 people.
Amazing.
And so my goal at that time was to bring in, since there was no perfusion school really nearby, was to bring in nurses and respiratory therapists and train them to do perfusion, which I did. I trained a lot of people before 1981, before the deadline in 1981.
Did you really?
Plus we had Stony Brook students for a while. So yeah.
Well,
so
it must have been challenging.
By the time I left, almost everybody was either a nurse or a respiratory therapist. But at least they had a medical background, so that when I worked with them, I could communicate with them on a higher level than the staff that I had when I first started. Yeah.
Sure.
I mean, I can give you a couple examples. They didn't use any ACTs at all. They had arterial filters, but no ACTs. They used wall water, and during rewarming, they would turn off the cold water from the wall. So they did have a case where a patient got severely burned. And so there were a couple of practices that were really outdated. But that's the first place I ever used cardioplegia, and that was not good. We had very bad results with crystalloid cardioplegia.
Really?
Terrible results with crystalloid. Terrible.
Well, we might get into that
Okay.
shortly, but clearly that was a real challenge.
Yeah, it was. I like challenges, and so, when I left that institution 11 years later, I mean, the surgeons really recognized the work that I did there.
Sure.
To bring that place up to what it should be in perfusion.
Where did you go next, Joe?
I went to Columbia Presbyterian Hospital in 1990, and I was there for about 4.5 years.
And you still lived on Long Island? That
No,
must have been...
I moved closer to. I moved after half the time I was at Montefiore. I moved up to Westchester, so I was closer to Montefiore. And then when I worked at Columbia, it was a little bit further, but Columbia's on the west side of New York, and it's pretty north, so getting there wasn't too bad from Westchester.
And where did you go after Columbia Presbyterian?
That's why I came to Medical University of South Carolina.
And tell me how that came about. Did they recruit you, or did you apply?
No, I applied for the job. It was a time in my career where my kids were young enough that I could move, and I didn't really like the union environment in New York City. I had trouble getting rid of some employees that were not the best, and the union would fight me on it.
Yes.
And, so I didn't want to be in that atmosphere anymore. So I wanted to teach, and I don't know. I always have dreams of the future, and one of them was to work with Jeff Riley and learn from him. So that was my dream. I said, if I'm going to go somewhere, I'm going to go someplace where I can really learn something.
So Jeff Riley was at Medical University of South Carolina at the time?
Yeah, he was chief there.
Okay.
So he recruited me at that point.
Well, that was a big move for your family, wasn't it?
Yeah, it was. My wife actually didn't come with me at that time. She took one trip to South Carolina. She said, I'm not moving here. So she said, you go and check it out, and then if you really like it, we'll come down. So my family came down 3 or 4 times. Every time they came down, they loved it even more. So by the time the 7 or 8 months were up, they were convinced. And I was living on my sailboat during that time. I brought a sailboat down from New York. So I was really happy during those 7 months. How beautiful. It was great. I had a great time.
This is pre-mobile phone era. Did you have a telephone on the boat?
Yeah, I had a cable TV, and also had a phone line on my boat.
Really?
Yeah. Had a phone on my boat, and with a line that went to the dock.
Yes.
And my rent was $175 a month, $5 for electricity, which included the little heater on my boat, and the cable was included. So my expenses were pretty minimal during that time. And I lived about 5 miles from the hospital, so I could be at the hospital really quick.
And what time frame was this? Was this the early 80s?
I got there in November of '94.
Oh, okay.
Yeah.
Okay.
Yeah, fast forward to '94.
Okay.
So 94. So it's 20 years that I've been there now.
I was going to say, you've
20 years.
been there the longest of any job.
Yeah.
And you've done a tremendous amount of work with the training program. How long was it before Jeff left the Medical University of South Carolina till you...
I think it was about 1988 he left. And 1998 he left.
Okay.
So 94 to 98. So we worked together for 4 years. And then he left, and he told me that he drove. I was up in Myrtle Beach because we had a contract in Myrtle Beach, and every 7 weeks we would do a case in Myrtle Beach. So I went up to Myrtle Beach for my week, and then he called me up and he said, I'm coming up to visit you. And he drove up and he told me he was leaving.
So when he left, were you the heir apparent, or did you have to apply for it?
I applied for it, and I actually didn't get the job. Somebody else got the job, and then they stayed for a year, and then they left. And then I guess I was the next one up. on the list. It's the next one up on the list. I told them when I first got there, I did not want to do management. I wanted to teach, do clinical, but I did not. I had Montefiore for 11 years managing 15 perfusionists at Columbia, and it wasn't really my goal to go there and be in management. I really wanted to do clinical and teach and do research. But then after he left, it kind of left a void. So
you did end up in management.
I stepped up to the plate, yeah.
Okay.
So for 13 years, I managed the perfusion program and the hospital
program, boy.
Both. So I did a hospital program, about 900 cases a year. We had 9 faculty that taught in the school and did all the cases in the hospital. So, it's like every emergency, I didn't run the schedule all the time. I tried to delegate it, but after a while, the other perfusionists came to me and they wanted me to run it because they didn't feel like everybody was being fair to each other. So I ended up getting day-to-day management back again. So and I took call for 10 years. After 10 years, first 5 years I took full call. The second 5 years I took second call. And after 10 years, I started in the PhD program, and I knew I wasn't going to be able to take call, so I told them I couldn't take call. So I finally got off call. I still did about 110 cases a year, 100 to 110 cases a year, mostly pediatric.
Really?
Yeah.
So that a big pediatric program.
Yeah, pediatric program is really good. They do about 300 cases a year, or we do 300 cases a year, and very good results. We have one of the lowest mortalities in the country. Our mortality is about 1% overall, and the average in the United States is about 3.5%, and that includes all comers. And our Norwood mortality is extremely low, so we have really good outcomes.
Wow!
So I like doing that. We don't do a lot of research, and so in terms of national rankings, I think we're ranked 18th or something, but in terms of mortality, we're better than most any other place.
Mm-hmm. So that brings us up pretty much to the present. Has your job evolved in any significant way in the last 5 or 6 years?
Well, when I got my PhD, I actually started, I knew I wanted to get into a PhD program, but there was nothing really available for me to get into part-time. I applied to College of Graduate Studies, and for some reason they allowed nurses to be part-time students. So I thought I was going to be able to get in on the same kind of way that they do it, but they said I couldn't be in the graduate study because I couldn't be full time. So I was really disappointed in that, and so I met with the professors there, and they told me, well, take this course in clinical research, get a master's in clinical research, and then all those courses are part of the PhD program. So you'll be able to transfer those. So it kind of started in the PhD program, but it was the master's in clinical research. So I started that and I finished that in 2005. And so that was my second master's degree. And then they were supposed to start a program in our college, and I was actually on the planning committee to help start that. But our college is very rehab oriented. There's a lot of PT, physical therapy, occupational therapy. And so they decided to make the PhD in rehabilitation sciences because there's so many PhD faculty in that area. So there's another component to it called health services. We have a couple of experts in health services. So that's what I ended up doing my research in, even though it's called PhD in rehabilitation health sciences. But mine is really more health services. And health services is outcomes research. So I finished that program in 2012, defended my dissertation. So that took me 3 years. But I had a lot of credits from before.
Sure.
So that's the only way I could do it. I was officially full-time. Full-time is 9 credit hours. So I was taking 9 credit hours a semester. And usually 6 of those were actual classes that I was attending, and usually 3 was independent study. So my 2 areas of interest was neonatal, long-term outcomes in neonates, and whether they develop, I was using ADHD, attention deficit hyperactivity disorder, as a marker. And I was looking at the outcomes in kids, and I was really interested in circulatory arrest versus cerebral perfusion. And the other area I did a lot of papers in was simulation. I was trying to develop a body of knowledge in simulation. So Those are the two areas I did most of my independent studies on. And then, yes?
Sorry to interrupt. The vibration on the phone, it got a couple texts or something. It came through on the audio. If you just take it off the table, you should be fine.
Okay.
So has it changed my job? To get back to your question, yes, it has changed my job because in 2012, after I finished my degree, we split our program so that we no longer, the college that I work for no longer provides the clinical component, except for our 40 cases that we do a year to maintain our certification. And so there are 2 faculty in the college, and the rest of the perfusion faculty all went to work in the hospital.
Okay.
So we split our program. It was more more traditional program. We were the only college that had that much faculty, we call faculty practice. Mm-hmm. So that comes with a lot of challenges. But I mean, in terms of the students, it allows me to devote my time 100% to the students. So that's great for the students.
Sure.
In terms of income, it makes it more difficult to fund our program because we lost a lot of clinical income.
Okay.
We don't have the expenses of those salaries either. So, but the way colleges work, there's a lot of overhead in colleges.
Yes.
So in order to pay the bills, you got to pay all the overhead first, the tax or the overhead, and that's quite substantial. And most of the income is related to tuition. So the bigger class you have, the more income you're going to have. So so in perfusion traditionally are small programs, so they don't really have that much income. So
what is your typical class size? And I assume you have a senior class and a junior class?
Yeah, junior class now is 18, and senior class is 14, and we're probably going to go up to 21 this year.
Wow.
And I like having multiples of 3, because when research projects, we do research projects with 3 students on a project now. So it keeps it's small enough that they can work, but it's big enough that they can divide up the assignments and the work between the group.
So a practical question, with 3 students on a research project, who becomes the first author?
Yeah, that's one of the things we solve early on when we first talk about that. We actually have research policies, and it talks about who gets credit as first author, and it's based on calculation of effort for each part of the paper. So I mean, if you have the idea for it, doesn't mean that you're first author. If you do most of the work, then you get to be first author. And it could change during the process. If somebody doesn't do their part, then we have that, we consider that. But we have research policies that the students have to sign, and the biggest section is on authorship.
Okay.
And I've taken that from multiple sources in order to solve that early on, because that always can be an issue. So a lot of times you'll see at the meetings, one student will be the first author, and then another student will present the paper. That's why, because they decided to split it up.
Okay.
So, and the first author really is responsible for the editorial part of it. So when the paper comes back, they're responsible to keep that.
They're the point person.
Exactly.
So tell me, what month in 2012 did you get your PhD, Joe?
It was August 2012.
And tell me, did you have a party after that?
Yeah, we had a pretty good party. We, I don't know, it's just, my wife got me this great t-shirt. It says PhD finished on it. So PhD finished. So I got a great t-shirt. And yeah, we had a party at my house, and it's pretty special. I was 59 years old. My goal was to do it before I was 55. But then they didn't start the PhD program until 2009, so I was kind of waiting for that to get started.
Yes.
I was in the first class, and there were 7 students in my class, and I'm the only one that finished. Nobody else in my class finished. Nobody else finished.
Wow.
I knew what I wanted to do for my research when I got into the program.
Yes.
Like I knew exactly what I wanted to contact all these families 10 years later and find out how their kids were doing.
Sure.
And then I wanted to see whether the ones that had circulatory arrest were doing better or worse than the ones that had cerebral perfusion. Because in 2000, we started doing cerebral perfusion.
Yes.
And the 5 years before that, those patients had circulatory arrest. So I had almost 13 years of data on patients. I just had to find the patients. So I found about 45% of the patients from that cohort. So
that's a pretty good percentage to find.
Well, when I send it out for publication, they say it's very low, but 10 years later, fortunately in South Carolina we have this consortium of all the pediatric, we're the only pediatric hearts program in South Carolina.
Really?
So we have a Children's Heart Network of South Carolina that maintains records on all these patients. So unless they move, or the other problem is people change their names a lot.
Yes.
You'll see as children get adopted or move, foster homes, or whatever it is, the names change. And that to me that was the hardest part, trying to keep track of who's who. Because, I was matching up the perfusion records with the surveys that I did. And so the surveys were on ADHD and a child health questionnaire, find out how they were doing. Because I wanted to have two different separate ways to categorize them as if they had ADHD. About 45% of the children have ADHD from that cohort.
And have you looked at enough outcomes to be able to say cerebral perfusion is better than circulatory arrest?
No, that's the latest paper that I submitted. We don't have enough data to show a difference between the two.
No, and not even any trends at this point?
No.
Okay.
One thing we found was that patients that have certain diagnoses that are associated with genetic disorder, like interrupted aortic arch, that group had over 80% ADHD.
Okay.
So that's what we published. So it's more genetic than it's not a modifiable factor that we could do in the OR. I'm looking for something in the OR.
Sure.
Whether it's hematocrit, alpha stat, pH stat,
blood flows.
Yeah, blood. Cerebral perfusion. There's a lot of good physiology on ADHD and neonates, all related to blood flow. So I thought that it was going to be a perfect. I thought that perfusion was going to be related to ADHD, but I haven't been able to show that. But still the numbers are very small.
Mm-hmm.
So.
And this is ongoing research that you're...
No, once I get this paper published, then I would like to maybe write a grant for a multi-center study, but I don't know if that's going to happen. I'm still trying to get this part of it published. The last part, I published 3 papers for my dissertation. The first one was on pathophysiology of ADHD related to bypass. The second one was on the prevalence of ADHD in cardiac patients and the effects on their their health status and behavioral issues related to ADHD after cardiac surgery. And then the third one is a relationship to the method of cerebral protection.
Okay.
And that's the one I really want to get published. So I'm working on that.
That's the holy grail.
That's the one I'm really working on.
Sure. Well, I'd like to shift focus now a bit, Joe, and ask you, as you look back on all the places you worked, instructors you've had, colleagues at your job, are there any surgeons or perfusionists or anesthesiologists that stand out as particularly memorable or somebody who really influenced you in a very significant way?
I think I took something from everybody. The first surgeon I worked for, his name was Dr. Wissoff, and he was very fast. He used to shake a lot, and almost like Parkinson's type shaking in the operating room but he was so fast, and he was an excellent surgeon. And I learned from him that if somebody's not ready to do something, that you should always be planning ahead. Like your next step should be in your... The reason he was fast is not because his hands were fast, is because he already had the next step of the operation planned, what he was going to do. So he would just move on to the next step and to the next step, and it taught me to think ahead, And when I worked at Nassau Hospital, it was a very small hospital, and it was the kind of place where it was like a family where everybody knew each other, and so that was a nice place to work, but I didn't really... I wanted to go do pediatrics again, so I went back to Long Island Jewish. Then I went to Montefiore, and the surgeons there were really great to work with. Most of them are retired now, but they were really great to work with.
Any names jump out?
Dr. Larry Attai, he was from, I think he's from Iran. He trained at that hospital in Montefiore under Dr. George Robinson, who was the chief, and Dr. Robinson ended up having aortic valve surgery twice. I ran the pump on him twice, and Larry Tai did the surgery on him. So we had a lot of challenges together.
Sure.
We had a lot of challenges together. And Dr. Brodman there, he was so supportive of me. So he took me up to Boston Children's Hospital. I used to like to do field trips. Whenever I wasn't busy, even when I worked at Long Island Jewish, I wasn't busy. We'd always go on field trips to other hospitals and try and learn, So we took a field trip up to Boston Children's to learn how to do Norwood operations. We never were that successful with it, but it was the early 80s, so nobody was really that successful with it.
Even Dr. Norwood had his problems.
Yeah, nobody was that successful. But he really tried. Dr. Brodman, he was an interesting surgeon. He's still alive, and I don't think he operates anymore, but his father was a general surgeon at the hospital. His mother was anesthesiologist at Montefiore. So a lot of times they did cases together. So he'd go like, Mom, give the protamine, And his wife was the daughter of the director of the hospital. So, he was all...
A lot of inbreeding.
Yeah, he was all connected in the hospital. He was a young guy. He was a resident there. And he went up to Boston Children's, and he went to the laboratory there where they have a couple of thousand specimens of hearts. Like every defect you can imagine, and there's just two professors there, the von Proggs, and they wrote this book on cardiac surgery and pathology of cardiac surgery, and they maintain this collection, and they were there, and he introduced me to them, and I went down to see it and everything, and he was just so supportive, and we worked there, and
sure.
So he was really good. So all the surgeons at Montefiore were very. When I left there, they made a really nice party for me when I left. So I went to Columbia, and I got to work with a lot of great surgeons there. Dr. Craig Smith, who operated on Bill Clinton. He's there. Mehmet Oz was a resident there when I started. Dr. Oz, and who else was there? Robert Mitchell, who's now the chief at Montefiore, he was there. That place was different because those surgeons were very, very young, but they were all they were 10 years ahead of their age in terms of their experience. And Eric Rose, who was the chief, he was 41 years old when he became chief, And everybody there, they didn't stay there long, most of them, except for Craig Smith. But they were so far ahead, and they taught me how to do multiple research studies on the same animal. So we would go to an animal lab and we'd do a study. We'd do 5 studies at the same time, They would be doing something on heart transplants. I would do something on low prime circuits. I never thought you could do that, but they showed me how to do multiple studies at the same time. Mm-hmm. Mm-hmm. So we did, there was a study on, they were developing a solution for a transplant solution. That was a 24-hour solution. So at the end of 24 hours, every day they would transplant the heart that they would take out. They would transplant the next day, and then they would take that heart out and transplant the next day. So it was every day it would be a transplant. So we preserve it for 24 hours and then put it in and put the next one in, And so the first time the heart came back after 24 hours out of the, oh my God, everybody was hugging themselves and they were hugging each other and jumping around the room. I never saw researchers react like that, They were just so excited. And then all of a sudden, about 10 minutes later, the heart fibrillates.
That was it. End of experiment.
So the solution wasn't perfect. That was the end of that. But we also did a Lazarus experiment, which I call the Lazarus experiment. So
Lazarus?
Lazarus, like in the Bible.
Raising the dead?
Yeah. So when they took the heart out of the patient for heart transplants, we take it back to the laboratory and start it up again on a Langendorf experiment.
Sure.
And then measure the effects of different drugs on the stroke volume. Some of these hearts had 400, 500 cc's of volume in each ventricle. They were huge hearts. So one day we had a patient with it was on a HeartMate, one of the early HeartMates. I was there for the first HeartMate at Columbia, and then the first one we did a right heart assist on there, which was so much fun. The Abiomed just came in. I didn't even read the book on it. I watched a video on Abiomed the night before, and I came in, and they said, we're having problems with the right side after we put this HeartMate in. I said, well, we could put the Abiomed in. So it was easy to prime. I watched the video so I could prime it, and we hooked it up. And just as we were about to turn it on, there was no power in the Abiomed. It was just dead. So I was with this cardiologist. He said, let's open it up and see if there's a fuse inside. So we took it apart, and inside we found a fuse, and we placed the fuse, and we got the patient on the Abiomed, and the patient survived.
Unbelievable.
So that
in
was
the
a little
meantime,
scary. That was a little scary, you know.
in the meantime, you were using the foot pump.
No, we actually didn't go on. We were like ready to go on. The surgeon said he almost ready to go on. You know, it was like he was cannulating, and we were like almost ready to go on.
Okay.
And all of a sudden, there was no power to the device. You know, so but we got it going again. So and the patient did well. So from what I remember, that was the first one we published. That first use of Abiomed with a heart rate. But with the Lazarus experiment, we had a patient one day who we got the heart for, and then they called me up. I came in and they said, you know, Joe, the patient's ejection fraction is 60%. I don't know if we should do this transplant. So they went out to talk to the family, and the family said, no transplant. So we couldn't, the heart was perfectly good. The donor heart was a good heart, but it was too late to send it anywhere else. So we took that so that was our control in the Lazarus experiment. We had a normal heart, and then we had all these other hearts with cardiomyopathy.
Sure.
So they're still doing a lot of work with that now. The cardiologist that's there, I think he publishes a paper like once a week. I see papers all the time. Daniel Burkhoff. He's a engineer and a cardiologist, and he publishes papers on heart failure.
Sure.
So,
well, to bring it up to the present, any surgeons stand out at the Medical University of South Carolina, Joe?
Well, I work mostly with the pediatric team, but Dr. Economides, who's the chief there now, he's very active in the Heart Association and a number of thoracic surgery societies, and he was on my dissertation team. My dissertation team, like everybody with a dissertation, they usually have 3 people on it. I had 5.
Oh boy.
I had Dr. Economides, chief of surgery, Dr. Bradley, who's the chief of pediatric surgery, who I work with a lot, Dr. Atz, who's the chief of cardiology, pediatric cardiology. My mentor, who is a health services research investigator, Dr. Kit Simpson, and she's my mentor for the last couple of years. And then there was one other person from the PhD program, Dr. Ellis. So I had 5 people on my team. So all of those people, I picked them because they're all so great. You know, there were people that really helped me and supported me.
So you didn't feel that the odds were stacked against you? You had some input into
No,
who...
they were helping me. They were helping me. But, you know, when I did my presentation for my, you know, some of them read it and some of them didn't read it. So when I did my presentation, they started to ask questions of things that they should have asked when I was writing the paper, you know. So
yes.
I had one little statistical problem that I had to solve, but they always find something. But so, I mean, they're all really good surgeons there. I mean, all the people that I worked with there have been really good.
So you mentioned some surgeons that stand out. You mentioned Jeff Riley earlier. Are there any other perfusionists?
Richard Chan.
And Richard Chan, of course.
Richard Chan I work with a lot. I work with Linda Mangiero in New York. She left. She was the chief before I got there. And then she came back after I was working there a year, I think. She came back, and she was my assistant chief, and then she became chief when I left. Yeah.
And I know from visiting the Medical University of South Carolina many years ago, you've got quite a faculty, but some of them have left the university. Do they still keep in touch? Do you have like meetings where everybody comes together?
Well, we have our annual conference, the Devices Conference, every year. So I started that in 1999. The person that was director that year asked me to try and come up with an idea for a continuing education conference. So we have a lot of faculty and former alumni that will come to that meeting. So we usually get 70 people, 60 to 70 people a year, and usually 20 of them are alumni or faculty that come back. So that's how we try and keep in touch with people. This year we did this thing called the Team Approach to Cardiac Surgery, which I'm going to do it again. And we used a TED Talk format, and we had 17 presentations by cardiologists, surgeons, perfusionists, and TED Talks. And so the idea is they come out and they don't have a slide with a title on it. They just start telling a story. and they kind of draw you in to their story. And then they tell you about something that they implemented that improved the patient care. And then at the end, they'll tell you like the outcome of it. And it was riveting. It's 20-minute talks. They're riveting. Everybody was fantastic last year. So we're going to do that again this year.
Good.
And we invite all the nurses from the hospital to come for free.
Great.
So we had about 250 people attend last year.
Sure.
So that's our meeting.
Well, while we're talking about technology, I'd like to shift gears again and ask you if you could comment on what you think were some of the major technological advances in your career.
Well, I think let me just phrase it this way. I think we still have a long way to go. I don't think we've progressed as much as I thought we were going to. Because I was early interested in blood conservation, I've always been interested in miniaturizing the bypass. And, I thought we were going to be a little bit further along than we are. I mean, the oxygenators have gotten smaller. The membrane oxygenators have gotten a lot smaller. So, but the patient population has gotten a lot sicker. So, the patients that we did in the 70s or 80s, we could probably do almost all of them without blood. But now, in the higher risk populations, we need to do it. In terms of centrifugal pumps, I think there's some benefits in that area, and some of the control features. Having shutoffs on the arterial line so we don't pressurize the circuit. We could never do the neonates that we do today. Inline monitoring is blood gases is really important, so we can control blood gases efficiently. In terms of anticoagulation, I don't think we've progressed that much. I always talked about the students about a paper in 1978 that looks at the 400 ACT level, Doty's paper. I mean, young Doty, Kisker, I think it is, 78.
Yep.
But, nobody's redone that study with coated tubings or anything. We're still using that number. There's still a lot of research that needs to be done, but, and the perfusion market has shrunk quite a bit. It's almost becoming a commodity in some ways, So I think we've progressed. I think probably the future is going to be smaller circuits and probably more uniform circuits and less customization, because the cost of medical devices is going to force it to go more uniform. So that we're going to be, in 10 years from now, we're probably using more uniform circuits or standard circuits rather than so much customization.
Certainly that's been talked about for a long time. Do you consider your circuits mini circuits at this point or not?
Not really. We've cut down priming volumes, but for instance, for neonates, a neonate might have a priming volume of 250. We're still, in the 250 range for priming volume. So we're still equal to the patient's blood volume. We need to be below 100 probably in order to prevent, avoid using blood.
Sure. Sure.
So we're not there with small babies. We're not there yet.
Sure.
So I think the pump's going to have to be up on the surgical field at some point. It's the only way to do it.
This is a bit of a loaded question, but what's your view generally of the cardiopulmonary industry? And you can cite experiences, or you can just answer in a general way.
I don't know. I'm very favorable in terms of the support that they've given perfusion. There are a lot of meetings around the country. I understand they can't support every single one. There's a lot of expenses involved with that. But I think they're very good in terms of their educational offerings. Some things we can't partake of it because of conflict of interest, but they do want to support perfusion through simulation, through through product demonstrations, but they're facing a big challenges in healthcare reimbursement because of healthcare reimbursement too. So, in terms of new technology, I think it's pretty slow. I think there's things that could be done to improve it. They kind of respond to what the perfusionists want. to a certain extent, and to what the market, that they see the market in the future. You know, like for instance, I'm glad they finally came up with a way to separate the cardiotomy return from the venous reservoir. They were doing it in Europe for a while. They finally came to the United States with it, and there's a lot of benefits to that. But I don't know. I don't really have that much interaction with industry except at our conference where they come and do presentations. And they've always been supportive, and
Sure.
they do that without being too commercial, you know, and make it more of an educational experience.
Okay.
Yeah.
You talked about simulation earlier as being an interest of yours. Is there a perfusion simulator at your program?
Yes, we have both. We have the Orpheus and the Califia. We have both. We have 2 rooms.
Really?
Yeah, and we just, this week, they put $50,000 worth of high-definition cameras and monitors in our simulation room. So I think we have a really good facility. Simulation is a challenge for faculty because it takes so much time. So as a program grows, hours and hours of time in simulation. So with the Califia, we let the students use that on their own. We train them on it, but we don't stay with them there all the time. So a lot of times we'll have labs with 3 students. And one student will run the pump, one student will run the simulator, and the other student would be like an assistant. And then they'll rotate, or 2 people in there. So once we go through the lab with them, they go back in there, they can practice as much as they want. And then we test them. With the Orpheus, because it's older and because it's much more fragile, we don't let the students in there on their own. So, but that is in a mock OR. I mean, we have hanging lights, we have a table. We inherited this room that was set up for OR training, was completely equipped like an OR. So when you go in there, it looks like an OR. We have lights. We have a camera in the light, just like an OR.
So is that simulation room or simulator room exclusively for the perfusion program?
Yes, it is. Yeah.
Well, that's a real benefit, isn't it?
Yeah, they have a simulation center on campus for the rest of the university, and they used to be in this room. So when they left to build their sim center, they left that room and they were going to dismantle the room. So there's about $700,000 worth of OR equipment in that room.
Wow.
And they were going to dismantle it, and fortunately, the dean agreed to give it to me, and that year bought us the Orpheus simulator. And we also have a thing called Sim Capture, which videotapes the student and can take up to 4 different cameras. So we have 2 angles on the student. We have a direct feed of the OR hemodynamic monitor and a direct feed of the blood gas monitor on the Orpheus. So the student can actually access that from home, and they can watch their simulation. And it also has evaluation forms attached to it, and you just, as the students do certain tests, you just check it off. And so when they take their finals, we have a master checklist, and as the students are doing what they're supposed to do during a procedure, we check them off, whether it's changing out an oxygenator or responding to a power failure. So we check that off, and then it automatically calculates their grade. And we can also annotate the video. So like, forgot to put the clamp on the arterial line, you can annotate the video so you can go right back to that spot and see where it is. So, and that's all saved, and that's part of the Sim Center on campus. So that goes to their server, so it's all protected. Nobody's carrying around videos of students or anything. But if the student wants to, they can log on and see what they do.
So I assume before a student in your program goes clinical, even with direct supervision, they are run through the simulation room.
Right. So what we do is the first semester we use the simulation room to teach basic skills like how to balance transducers, hemodynamic monitoring, just occlusions, prime the circuits, those kinds of things. So we don't really need a simulator for that kind of stuff, right? But the equipment's in that room, so we use it. Second semester, we teach skills. We break down into bypass and skills. So we do on and off bypass. We do wrap, vacuum assist, and so cardioplegia delivery. That's main. So by the end of the second semester, the students have all those skills down. They can go on off bypass, give cardioplegia, do wrap, vacuum assist. And in the third semester, we actually do cases in there where the student comes in and and it's just like a real case from beginning to end. And we have the monitors. We can actually put an operative procedure on the monitors, so we can coordinate that with the, so say give cardioplegia, you can see the cross clamp go on, and they give cardioplegia, and they say, well, the only thing that's not realistic is there's not blood in the circuit. That's the only thing.
Well, I thought you were going
blood.
to say the only realistic thing.
They don't have blood. The patient's pretty realistic.
Surgeon screaming.
Yeah, well, so we do a lot of videos in there.
I know you do.
Yeah,
You've done
we
some
we do
good
video.
instructor, bad instructor.
No, but we also do videos where all the students play roles. They played a role of the anesthesiologist. They played a role of the student, of the surgeon, the nurse. And we've done videos on poor venous return, oxygenator failure, cardioplegia problems, water to blood leak. That's the funniest one because the perfusionist is telling the surgeon he has too much venous return. And the surgeon's like, he can't handle it. He throws down his instrument and goes, what do you mean too much venous return? Perfusionists never complain too much venous return. And then you see like a little cutaway of him pouring like this gallon jug into the heater cooler every couple of minutes. That's really a funny one. But we've done a whole bunch of them. We're going to put them all on AMSEC University soon. That's our plan. We're going to get them all up there. So we actually did an air embolism one with retrograde cerebral perfusion. And so we actually edited in Animal Lab to it. So you actually see us do reverse perfusion, air coming out of the ascending aorta, everything.
Amazing.
But it's done in the sim lab. It was done in the video, the interaction, the discussion between the perfusionist, everything is done in the sim lab. But then we edited in the heart and the air and everything. You see the air going through the arterial filter up to the arterial line. And then, the perfusionist is distracted by the anesthesiologist because the anesthesiologist shows her something on an iPad, Angry Birds game. They start playing Angry Birds in the middle of bypass. And so the next thing you know, air is going up into the patient. And so the surgeon says, what do you mean this air? He goes, you know what to do? Did you practice this? And it goes through the whole thing. And they're all like fumbling, trying to figure out what to do and everything. And I don't think anybody's ever done that, like recreated an air embolism. So
I don't think they have.
I really believe that if students get exposed to those things and talk about it and see, and even acting in the video, participating in that if it ever happens to them, I think they'll be able to manage it a lot better.
Well, that actually anticipated my next question. Obviously, a lot of work went into creating these scenarios, a lot of front-end creation. What sort of feedback have you gotten from students who have spent time in the simulator?
They can't get enough. That's the problem.
Really?
They can't get enough. That's all they want to do is simulation. They want to do as much as possible. They can never get enough. But the thing is, we have a limited amount of time that we can spend with them.
Sure.
So it's usually it's one-on-one. So that's why we developed a second room for simulation where they can go and practice on their own, and then come in and have us test them. So, so I think that's been a big help, especially as our program has expanded in size.
Sure. So. I'd like to ask you now, Joe, if there are any cases that stand out in your mind, good or bad, as just really memorable cases.
Yeah. I'll talk about the good ones. The bad ones, I don't want to even think about anymore.
Sure.
They were mostly early on. But the good one, I had a really good one that we wrote up for and published. It was a patient that had driven down from New Jersey to Myrtle Beach. And he went to play golf, and about a day after playing golf, he developed really bad shortness of breath. And they diagnosed that he had a pulmonary embolism. So they contacted us, asked us to bring him down to MUSC. So we didn't have an adult ECMO program at the time. We have pediatric ECMO, but no adult program. So we put together a circuit with a biopump and an oxygenator, and we hopped on the helicopter. And I went with one of the surgeons, and we went up there, and we put the patient on bypass in the hospital. Meanwhile, the ambulance was driving up from Charleston. So by the time we got there and got cannulated, the patient was on bypass. We put it in the ambulance, and we drove back to MUSC. And then the surgeon did a good thing. He decided to operate in the morning, not to operate that night, because we were all up all day, and we were all pretty exhausted from the whole transport thing. So the patient was stable, so we went home a couple hours and came back in the morning. And this was an amazing case, because as soon as we went on bypass, I saw that the venous saturation was like almost 100%. So I knew the patient had an ASD, and I told the surgeon, I said, I think this patient has an ASD. And, so it turned out that because his right-sided pressures were so high, blood was flowing across his ASD. And as soon as we went on bypass, we were getting oxygenated blood into the venous line. It reversed. So that was interesting. And then the resident came up with this idea. He said, look at this paper, and I don't remember what paper it was, or where he found out about it, but he said, let's look at this thing where you do retrograde pulmonary perfusion. So, it was kind of on the spot thing. This patient had ASD. So the surgeon decided to take a cardioplegia cannula and stick it across the ASD into each of the pulmonary veins. And we perfused the lungs backwards until we got all the clot out of the pulmonary arteries. And I have pictures of all the clots and everything. And so we just perfused for a very short time, just enough to clear out the clots. And I don't remember what the pressures or flows were right now. And then, came off bypass, and the guy went home in a couple of days. He was like perfectly fine,
Amazing.
Totally recovered. So, of course, I had to go back in the literature and look this up. And there's like all these papers written in 1965 about pulmonary perfusion, and retrograde pulmonary perfusion for pulmonary embolism. And they did these dog studies, and they looked at pressure and flow and time. And they showed that if you have over a certain pressure for a certain period of time, that you develop pulmonary edema. But if you could do it for a short enough time at low enough pressures, that the dog's lungs were not damaged. And so we were fortunate in doing that. So we published that, and that's been cited quite a few times, that paper.
I bet it has.
I belong to ResearchGate.
Yes.
Do that, right? So you see every time you get something gets cited, that paper's been cited a lot. So I thought that was really cool. I said, why didn't anybody have to think of that before?
Sure.
When you do a pulmonary embolectomy, watching them trying to pull clots out of the pulmonary arteries, things are breaking off. You're not getting down into the arterioles or anything. Mm-hmm. So it makes so much more sense to do retrograde. So that was a great case.
Sure.
So it turned out that Jim Deering had done a case 20 years before, a similar one. Not with retrograde perfusion, but put a patient on ECMO and brought the patient to. So, we presented it at the M&M conference, and we were all excited. And one of the surgeons said, "Oh, that's no big deal. We did that 20 years ago." But so anyway, but we published it anyway.
Well, it's obviously you still enjoy doing perfusion. Mm-hmm. What aspect of perfusion do you enjoy the most, Joe?
I do mostly pediatrics now.
Oh, so, you do?
Yeah, that's all I do is pediatrics now. Because I'm only doing 40 cases a year, I can't really maintain competency in every area. I don't really want to go into the operating room and not feel like I know exactly what I'm doing. And with the pediatric team, I try to remain engaged with them. I go to all their meetings, all their conferences with the surgeons, and participate as much as possible. So I really like doing the pediatric cases. Not some of the long redos so much anymore.
Sure.
But the straightforward cases, especially like a switch. I love doing arterial switch. When I was at Columbia, the surgeon there was a master at arterial switch, but I never really got to watch the details of it. But now we have a 60-inch monitor in the OR, like about 10 feet away from the pump. So you can see every detail, every stitch of every operation. And it's just fascinating. I love that. So arterial switch, Norwood, interrupted arch, all the neonate stuff I love. I love that. To me, that's the most fascinating.
I'm going to ask you briefly about teamwork. Mm-hmm. We've this interview is going a bit longer, but I want to cover all the areas. Okay. What can you say about teamwork? How important it is? Maybe your approach to teamwork at your center.
Okay. We have in the pediatric side where I work now, we have it's called a Room 2 crew because we work in Room 2 primarily. And so we meet once a month. And it's a one place I would say there's some other places where I felt very comfortable, but there, and everybody on the team is very outspoken. If they feel anything that needs to be improved, nobody will ever hesitate to speak up, and they feel very comfortable. And the anesthesiologist that runs that has kind of set the tone for that. And we have social events together, and we do a really good time out in the beginning of surgery. Everybody really participates in that, and I can't tell you how many times I've caught something, or the nurses caught something, or anesthesia's caught something that somebody missed that was really important. One day, they were given the wrong dose of antibiotic, and I knew I was given a dose into the pump, so it should have matched mine. And when the anesthesiologist said the dose, it was about 3 or 4 times what the dose was supposed to be for the patient. And so that's happened with numerous other things during the timeout. And there were days when, if you even talked to the surgeon before the surgery, they would snap at you. You don't know what you're doing, why are you asking me that question, right? But today, it's completely different.
Sure.
It's like, you have to speak up. And so that's the biggest change in teamwork. That's the biggest difference than the past.
Sure. What do you think are the personal attributes that make for a good perfusionist, Joe?
I think it's somebody that needs to. One thing is not give up. That there are certain cases that are going to go much longer than you expect, and just stay focused and worry about finishing that case, and then you deal with whatever else you have to deal with. Stay focused. In terms of skills, I think it's somebody that's open to new ideas, and somebody that's scientific in terms of their interpreting practice, and not just make a decision based on one case, but look at the literature, and then.
You're alluding to evidence-based.
Plan ahead to what you're going to do.
You were alluding to evidence-based perfusion.
Yeah, I mean, it's sometimes there's no evidence with some of the things we do. It's pretty hard to find, but and I really feel that as much as people want to be independent, that too much variation is not good. Now we should come to some kind of consensus on how we're going to do it. We just went through it recently with something with our team, and we all talked, and we figured out we were all doing something slightly different, and we all said, okay, come on, we have to figure out we're going to all do this exactly the same way, because we're changing something else, and we can't have all these other variables going on.
Right.
And everybody was really good about discussing it and coming to a consensus on what we're going to do to try and reduce that variation. So if you are not the type of person that's willing to give up your independence, then you're going to be you're not going to be a good team player, So that's what I look for in a perfusionist. And I don't know, I've had a lot of good people that I worked with and trained. Enthusiasm is very important. I want somebody who's enthusiastic at work. Mm-hmm. I don't want somebody that's looking to leave.
Well, this may be a difficult question, but what does it mean to you to have been a perfusionist, Joe?
Okay, to be a perfusionist. So,
yeah.
I mean, it's given me a lot of opportunities that I never thought I would have.
What sort of opportunities?
Because it's a small profession, I think the ability to participate at a very high level may not exist in other societies. It's not really competition. It's everybody working together to try and improve the profession. So I think that's one aspect of it that I really like, that it's a small group. You get to know people on a personal, professional level, and also, most perfusionists are adrenaline junkies, so that's what we get to do. We enjoy that part of it.
Sure. So you'd say that there were a lot of personal satisfactions being a perfusionist for all these years.
Yeah, I'm not always. I'm not always satisfied. I'm always looking like the next thing, you know, like or to grow. I want to continue to grow. But as my career is kind of towards the end, almost, you know, I at this point I have different objectives than I did 5 years ago when I was trying to finish the PhD program. Now I'm trying to move the program to a master's degree level, and I want the program to be really strong. We need good perfusion schools. We need high quality perfusion schools, and I'd like to see a uniform degree for all the perfusion schools. So those are the things that I would like to work on in the next couple of years.
Sure.
So that would be make me satisfied that I contribute something to the profession.
Well, let's bring that back to AMSECT in particular, and how important AMSECT has been in your career and in your feelings of personal satisfaction.
Well, I mean, the first meeting I went to was in 1975 in Chicago. I've been to quite a few AMSECT meetings. I missed the 50th one 2 years ago because I had to work the 50th anniversary. But AMSECT has provided a lot of opportunity for both me and my students to present, great learning experiences, ability to interact with a lot of perfusionists, also people that I can use their institutions for clinical instruction for our students. So I come to AMSECT, I see perfusionists from all over the country where our students are. And I see the students interacting with perfusionists for the first time as their first meeting. So there's a lot of opportunity at a meeting like that, a national meeting, that you don't have when you're kind of isolated in your own institution.
Sure. Well, do you have any closing thoughts on what you'd like to say to the new generation of perfusionists, Joe? I know we've covered quite a bit today in this interview, but any words of wisdom?
Yeah, my major thrust would be to continue your education as much as possible. Learn about statistics so you can understand how to do quality improvement. Hopefully some of the skills that you learned in school, even if you don't use them now, you'll use them 10 years from now to improve your practice. And do the things that you like to do in perfusion. So if there's certain areas that you really enjoy doing, whether it's platelet gel, blood conservation, looking at outcomes after myocardial protection, reducing blood volumes in pediatrics, long-term outcomes, whatever area you're interested in, that you get those skills so you can do a really good job with that, and that when you do eventually present information, that it's really valid and that people can use it to help. You can help other people with that information and publish.
Well, very good.
Okay.
Really have enjoyed our conversation this afternoon, and I want to thank you again for all your contributions over the years. You've got, how many students are out there that have graduated under your tenure?
Probably, I mean, I started as a clinical instructor. When I first started, I was a clinical instructor. I've always been a clinical instructor, so I can't even count those. But since MUSC, probably 200 from MUSC.
It's pretty impressive.
But before that, I always had students. Even when we were at Columbia, we were affiliated with 4 clinical programs. So,
sure.
So there's a lot of people that, you know, and those people have trained other people, so goes on and on, you know. So that's
exponential.
Yeah, it is, definitely.
Well, Joe, thank you very much.
Thanks
for taking time.
Sure, my pleasure.
Okay, Andrew.
No, that's good. It's only 3 o'clock.